Wish you a very good morning to all my dear students. So in our physics, we are in revision of yearly examination, and in our previous video, you have seen that answer key of section B and C. And today I want to give you answer key of section D. All the numericals are there, and one of the PDF file which I have made. So you can see that. So from that also you can find out the solution and find out the answers of all the numericals. Even you can see this video also. So all things are same. So here section B we have already completed. Section C also. Somewhere values are changed, that I have informed you. Some extra also there, just little bit value change. So section C, maximum number of numericals are there. So all the numericals we have solved in our previous video. Now come to the section D. Here, my dear student, question number 6 you will see in your section D. So in that, in class also I have mentioned, in video also I have mentioned. In question 6, a car accelerates uniformly from 18 km to 36 km in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. So here u we can consider as 18 km per hour and we can consider as 36 km per hour. Now it is in kilometer, so we have to convert in meter per second. So what we will do? So here 18 multiplied by 5 upon 18 and 36 multiplied by 5 upon 18. So you will get 5 meter per second and you will get 10 meter per second. So here first equation motion, the formula we will use, v is equal to u plus at. So what we have to find out first? Acceleration. So a is equal to v minus u by t. So 10 minus 5 upon 5. So a value will get 1 meter per second square. All students must see that the unit is very much important. So acceleration unit is meter per second square. Okay, so here please be careful. Don't write a is equal to 1 only. You have to write unit also. Now for the second, we can use the second equation of motion. S is equal to ut plus 1 by 2 at square. So S is equal to 5 into 5 plus 1 by 2, A is 1 and 5 square. So answer, the distance covered by the car in time, you will get 37.5 meter. Okay, so A is 1 meter per second square and distance covered S is equal to 37.5 meter. Question number 7, page number 44. A train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, so find out the acceleration and the distance traveled by the train for attaining this velocity. So here we have to find first of all acceleration, and after that we have to find out the distance traveled by. So first we will use we need to convert meter per second that we did in a previous sum. So v is equal to 0. Sorry, here u is equal to 0 because beginning velocity is 0 and after velocity, that is 72, final velocity 72 km per hour. So when you convert into meter per second, it is 20 meter per second. So time is 5 meter time is 5 minutes is given, so 5 into 60, that is 300 second you will get. Now using the first equation of motion, v is equal to u plus at, so a is equal to v minus u by t, so 20 minus 0 upon 300, so 0.067 or approximately a value you will get 0.07 meter per second square. Now for the second, the distance travelled by the train for attaining this velocity, we can use third equation of motion. So third equation of motion is b square minus u square is equal to 2as. So therefore v square value is 20 square and u square is 0. So 2 into 0.07 into 5. So at the end you will get answer S is equal to 2857.14 meter. If you want to convert in kilometer, it is 2.86 kilometer. Okay, so that is why units are very much important. So you must write unit. Now come to the question number 11, page number 282. Question number 17 is there. Now calculate the work required to be done to stop a car of 1500 kg moving at the velocity of 60 km per hour. So m is given 1500 kg, u is given 60 km per hour, we have to, and the velocity is what? 0. So u we need to convert into meter per second, 60 into 5 upon 18 meter per second, so 50 upon 3 meter per second as a u you will get. So w is equal to 1 by 2 mv square minus 1 by 2 mu square. By keeping the value, you will get w value minus 2,08,333.3 joule. If you want to convert in kilojoule, it is minus 208.3 kilojoule. So that is your answer. Okay, both answers are acceptable, so don't worry at all. Now come to the question number 12. The mass of the earth is 6 into 10 is to 24 kg and that of the moon is 7.4 into 10 is to 22 kg. If the distance between the earth and the moon is 3.84 into 10 is to 5 kilometer, calculate the force exerted by the earth on the moon. And gravitational constant value is given 6.67 into 10 is to minus 11 Newton meter square per kg square. So which formula we can utilize? We can utilize the formula F is equal to G m1 m2 upon r square. By keeping the value of each G, m1, m2 and r, the F you will get, the force exerted by the earth on the moon is 2.01 into 10 is to 20 Newton. So this about all the numericals from your physics, starting with section B to section D. All the numericals, answer key is given to you. Here also we discuss some of the most of the numericals and their answers. Okay, so prepare it nicely, get good marks, and it's from my side, best of luck and get good marks. Thank you. Have a nice day.